when you set out to build automation, the clean logic you design in the tool, say, within n8n, is often only about 40% of the actual work you do.
40%. And that remaining 60%.
Yeah.
That is a massive hidden tax of complexity. It's all the operational friction that sits, entirely outside the workflow canvas, and no tutorial ever shows you that part.
Welcome to the deep dive. Today, we're taking a really focused look at the practical reality of building reliable automation, especially with tools like n8n. If you've ever felt that frustrating lag between having perfect logic and, well, making any measurable progress, this dive is for you.
Yeah, we're really targeting that common confusion. Why does progress feel so slow even when your node configuration is, technically correct? Our mission here is to kind of reset expectations and make that learning curve a lot more predictable.
We're going to dissect that huge 60% hidden tax that you really have to plan for. We'll also establish the 3 essential layers for building stability, from simple workflows all the way up to AI agents.
And we'll cover why focusing on measurable business impact. The ROI always beats chasing the flashiest new tech.
Okay, so let's unpack this idea first. The 60% hidden tax. The tutorials, they show you this clean execution, the success path, but they abstract away all the operational friction.
You have to, right? But that friction comes from interacting with the messy reality of the internet. We're talking about external factors you can't control with just a setting inside n8n.
Like what, specifically?
Think about things like OAuth tokens that expire exactly mid-execution, or API rate limits that are completely undocumented, or, sudden changes to what an external system sends back to you.
And crucially, this must include infrastructure concerns, which I think are often the most frustrating because they feel totally outside your control.
Oh, absolutely. We're talking about compliance issues. Maybe an SMS message gets rejected by a carrier because of its formatting, or an email is blocked because of sender reputation.
Things you wouldn't even think to check inside the workflow.
Or even more fundamental stuff. The host machine's firewall rules, Docker networking, SSL certificates. None of these problems live inside a single n8n node, but any one of them can stop a workflow dead in its tracks.
So the failure happens way upstream or downstream, and that makes debugging feel impossible.
Exactly. When you're debugging, the failure has often happened outside the logic itself. If a firewall rule is blocking traffic, n8n doesn't give you a clear firewall-blocked error. It just looks like a generic timeout.
That's a vital distinction. It sends you down a rabbit hole looking for a bug in your code that just isn't there.
That's the tax. And struggling here isn't a failure to learn the tool itself. It's proof you're actually wrestling with the reality of integrating real-world systems. You're engaging with the 60%.
So if the logic is sound, what single factor most often causes a real workflow to fail?
It's the operational friction outside of the workflow logic, like expired tokens or firewalls.
So let's hit pause on that for a second. You're saying automation itself isn't just one monolithic thing.
Not at all. That's a huge shift in perspective, but it's critical. Automation has, let's say, 3 essential layers that you have to build in order, like a pyramid. If you skip a layer, everything you build on top of it just becomes unstable.
Okay, so let's start with layer 1, the foundation.
Layer 1 is just workflows. These are strictly rule-based and predictable. You know the exact input, you know the expected output. This is where the highest, most predictable ROI lives.
So moving data, syncing tools, sending notifications, the basics.
The absolute basics. And
Right.
if this foundation isn't solid, nothing built above it will stand up. You have to get layer 1 stability first.
Then we can move up to layer 2, which seems to be the sweet spot for a lot of people.
Yeah.
AI-assisted workflows.
Yes. Here, the AI is a useful tool, but it is explicitly not in control. The main rule-based workflow structure from layer 1 still owns the flow and all the error handling.
So we're just using AI for small, specific tasks inside that rigid structure.
Exactly. Think classification, summarization, maybe some simple personalization. You still have guardrails. You still know exactly why the workflow runs and what happens if the AI gives you a weird result.
So why is jumping straight to complex AI agents so unstable in automation? A lot of tools are promising the agents-first approach.
Because it's a universal law of automation, not just an ANN thing. Layer 3 AI agents is the top, most fragile layer. They use memory, they select their own tools, they make complex decisions.
And if you haven't mastered the basics,
You're lost. If you jump straight there without mastering layer 1 fundamentals like handling API errors or designing failure paths, it just becomes chaos. You can't debug an agent if your basic data movement is unstable.
So the rule is, workflows first, AI second, agents last.
Yes. Agents lack that rule-based foundation and error handling needed for predictable behavior.
Okay, let's dive into the core technical side. Most automation problems, they don't start with bad logic, do they? They start with data structure and movement.
Right. And
Yeah.
people see JSON, curly brackets, colons, and they mentally check out. They think it's some inscrutable code just for developers.
When really it's just a consistent data structure.
That's all it is. It's like an online order receipt. Product is shoes, size is 42, price is 99. It's just a name, a value, and where that value belongs.
But the challenge is that one tool might call it size, and the next tool expects foot measurement.
Precisely. And that's where your workflow breaks. So the real work isn't just reading JSON. It's mapping and transforming the data shapes so the next node can understand it. That's half the battle.
And the other half is getting it there. Which brings us to APIs and HTTP.
Yeah, the underlying language of how tools talk to each other. What's important to realize is that the native n8n nodes, the ones with the nice interfaces, they're just convenience wrappers around standard HTTP requests.
But you understand the core patterns.
You can connect to literally any tool. You just need to know the method, like GET or POST, the URL, the headers for authentication, and the body for sending data. You're no longer limited by what's officially supported.
And the final piece of the trio, webhooks. This kind of flips the whole thing on its head.
It does. Instead of your workflow going out and asking for data, a webhook lets an external event, like a payment or a form submission, trigger your workflow immediately.
It makes them real time.
It turns them into real-time responsive systems.
So what fundamental concept makes n8n automation predictable at scale?
It's understanding how JSON structures data and how APIs move it between systems.
Okay, so once we have data moving cleanly, structured as perfect JSON, we might hand it off to an AI model. This is where people get really distracted by prompt engineering.
It's a huge misdirection. We have to remember the fundamental rule. An AI predicts the next token. It doesn't actually reason like a human, so its output is only as good as the information you give it.
So inside a workflow, you have two components. You have the prompt, which tells the model what to do, like classify this support ticket.
Right. But the truly critical component is the context. Context tells the model what to base its decision on. It's all the surrounding data you deliberately feed it before you give it the prompt.
So we're not just talking about the ticket content. We're talking customer history, priority rules, maybe even examples of past tickets.
Yes. The ledger of truth. Without that detailed context, the model just guesses. And the risk is that a confident guess looks like a made-up answer, a hallucination. It's not a bad model, it's a failure of input engineering.
So we're not just prompt engineers, we're context engineers.
That's the key insight. Good context gives the model a clear, constrained path to a correct decision. It makes the AI output predictable instead of surprising.
So then how do we prevent an AI model in a workflow from making a confident guess?
By providing detailed context about customer history, rules, and priority information.
This brings us to a crucial shift in mindset then. It moves us from just being builders to thinking more like process engineers.
Right. The builder starts dragging nodes onto the canvas, fixing problems reactively as they pop up. This just leads to fragile, patched-together systems. They're constantly firefighting that 60% tax.
Whereas the process engineering approach is different. It starts before you even touch n8n.
It's radically different.
Yeah.
You map the entire process on paper first. What triggers it? What's the minimum data required? Where are the 5 places it could fail? And what's the plan for each failure? What's the final measurable outcome?
It feels slower up front, I'm sure. More planning, less building.
It is. But that investment means the finished workflow is inherently easier to explain, to debug, and to extend later without causing, unexpected ripple effects.
And this has a real business impact because clients don't pay for complexity. They pay for reliability. They don't care how clever your setup is.
They care that it works and that it keeps working. When you think like an engineer, you anticipate those failure modes we talked about. You build in retries and notifications. That's what clients actually value.
So what is the ultimate metric clients rely on when paying for automation?
Reliability and measurable business impact, not the complexity of the workflow itself.
Okay, so let's talk about a common trap we all fall into. Tutorial hell. Watching videos feels so productive. The outcome is always guaranteed, so it feels safe.
But you don't learn automation by watching someone else click buttons. The real learning, that muscle memory for solving the 60% tax, It only comes from building your own workflows, purposely breaking them, and then fixing them.
That active braking part seems essential.
It is, because over time, you start recognizing the patterns. Errors aren't random. They fall into just a few categories: missing data, bad credentials, an unexpected data shape from an API, or logic that just missed an edge case.
It stops feeling chaotic and becomes more like pattern recognition.
Exactly. And, a vulnerable admission. I still wrestle with prompt drift myself sometimes when a model updates and suddenly needs a refined prompt, but recognizing the patterns just makes the fix so much faster.
So when that error shows up, don't just copy a solution. You have to understand why it failed in your setup and why the fix worked. That's the only way out.
Right. So what's the fastest path out of just watching tutorials?
It's building real workflows, purposely breaking them, and analyzing why the fix worked.
Let's talk about the final metric: business value. Your clients, your stakeholders, they don't care about webhooks or JSON. They care about outcomes.
Time saved, money saved, errors reduced.
Exactly. That's why the best strategy is always to start simple. Focus on systems that are predictable and measurable. A boring workflow that saves a team 2 hours a day is incredibly valuable. It's easy to explain, easy to price.
Way more so than something flashy but vague, like an unconstrained AI agent that maybe saves time but has no measurable guardrails. Your real job is translating the technical stuff into business impact.
That's it. What cost is removed? What risk is reduced? If your process is predictable, the possibilities are huge. Whoa. Imagine scaling a simple, predictable sync to 1 billion queries without worrying about it collapsing. That stability is the true value.
And that's what transforms you from the automation builder into a long-term partner.
You have to track it. Track how often it runs, what human task it replaces, and the results over time, the hours saved, the errors prevented. Those numbers build trust.
So what single action transforms an automation provider into a long-term partner?
Tracking the measurable results, like hours saved or risks reduced over time.
Okay, let's unpack this core message one last time. Learning automation feels messy because, well, real-world automation is messy. The key is recognizing and planning for that massive 60% hidden tax.
Yeah, the path to building reliable systems is respecting those 3 layers. Foundations always beat shortcuts. Mastering how data moves with JSON and APIs, and applying that process engineering mindset before you even drag the first node.
So that frustration you feel when something breaks, that confusion is actually proof that you've moved past the easy demos and into the challenging but rewarding world of real systems.
Exactly. Progress looks like confusion before it turns into clarity.
So here's a final thought to leave you with.
If boring, well-designed, reliable processes yield the highest measurable ROI, how many of the flashy new AI tools you see online are actually distracting you from the most valuable automation work your organization desperately needs? Think about that ratio of stability to flashiness.
Thank you for sharing your sources and joining us on this deep dive. Go build something stable. Go build something predictable.